Um, and I think with Joe's suggestion, I mean, Joe should start us with a song.
Oh, I don't remember how it goes anymore.
Yeah, fair enough. But would you like to start us off, even if not in song?
Sure. So there once was a story. um, anyway, basically over the last week, I've been after everything's gotten settled in here, I've done a few. Like I hit up that. I've been trying to take steps to get to serialize the surveys for DC, the DC survey object. It's still involved, but part of that, I've taken a few steps forward with it, just trying to unify the 2D and 3D dipole receivers and sources, because there was essentially nothing separating them in the code base. So I just did work to combine them. Essentially all the forward operation, all the 2D or 2.5D necessarily stuff gets done by the 2D simulation class. So it just makes it, less repeated code. What else? Yeah, just kind of been going through trying to clean up other things wherever I see them. Just, yeah.
Joe, what do you do with like a 2D and 3D survey? Because like let's say 2D survey only takes like a 2D array, whereas 3D survey takes 3D array. Like what do you do with that?
So the 2D survey takes the the source list that are 2D dipoles, or that are dipoles, right? Mm-hmm. So the only way that it distinguishes between 2D and 3D is that the array locations you give it would be a list of two-dimensional locations.
Right.
Whereas when it's a 3D, you give it an array of three-dimensional locations.
Mm-hmm.
Everything else is the same.
Oh.
Like it doesn't need anything else.
Right.
It would be great though if the 2D could sort of remember the mapping to go back to 3D. Right? It's fairly easy to go from 3D to 2D, but to bring it back to 3D would be kind of nice. I don't know if you thought of something.
So I've been thinking about and playing around with actually doing a 3D, like taking into account 3D locations if you do a 2D simulation. There are just a few little places in the code that need to be modified. And then we'd also have to add an option about the profile, like the direction of the profile, or just automatically coming up with that direction if it's not given. I've done some work with that in the past as well for like 2D gravity modeling, automated that part. So I should be able to use that pretty quickly and get that in.
Yeah, it's more like a long line, right? You need to convert your X into a long line, and you only have a Z.
Yeah, I compute XY to a long line.
Yeah.
But
that'd be great, because if we could have like let's say a 3D survey, and then just say those are my line indices, just run all the 2D inversions, and then be able as a QC process.
Yeah,
that would be pretty slick, because right now it's a lot of scripting, when you want to do this.
Yeah, I mean, you can definitely still do that kind of thing with a 3D inversion, right? But it does take longer.
You mean to run a single line in 3D?
Yeah.
Sure. yeah. That's true. If you do actually, probably doesn't matter that much.
But just like I said, just unifying it, since there's not really, like, all the code was, looking through it, the code was essentially the same between the two of them.
Yeah, so before the 2D survey was, we're just like putting zeros in the third column or something, right? And then we knew it was a 2D. I think it was a mesh generation, the survey generation. That's what we were doing. Anyway, yeah, that makes sense.
A lot of the stuff with the simulation refactor made it easy to combine them. So that's nice. I like that.
That's encouraging.
Yeah.
Soggy.
Yeah, I'm not sure that I have a really big update.
Making sure Daniel's fed.
That's probably what I'm doing in these
Yeah.
days, like Daniel's having hard time. Like, so like Daniel got this, what they call like a 4-month sleeping regression. And we're absolutely having a hard time. So he's like staying up until 3 to 4, 2 to 3, and just sleep through until like 11 to 12. So we're trying what we could do to change that, but so far it's not working well. But he's growing well, and like he's pretty healthy, so we're not worrying too much. And additionally, I'm working on more like hydrological data in these days. So it's a little bit of out of geophysical realm, but it's an interesting problem because once you figure out like where are the clay distribution, then the question is like whether two aquifer is connected or not. So what you can tell is like from the geophysics is like it's a texture models, and you can say, oh, if there's a clay boundary, it may be disconnected. But it's slightly different from the hydraulical connection. So we're in the process of like comparing, like if you got multi-completion well and look at the hydrograph and then how well the geophysics did to figure out the connectivity between the aquifers. So yeah, so that's why, yeah, mostly just looking at the data and then figure out whether that's connected or not. But later, I think I'm planning to kind of quantify, like make a little bit better, more numerical way to figure that out. But at the moment, I'm just learning a little bit about hydrological data. So it's not quite related to SimPEG, and that's what I'm doing basically these days. So.
Do you have any plans to go about like a coupled approach?
Yeah. Yes. That's the next step. At the moment, we're focusing on what airborne EM can do. So we're like really digging in, like we're drilling down to what we can really tell by using airborne geophysics, considering all the assumption that we've made, and then comparing that with like the real ground truth data from the flow data. Then next step is coupling the airborne geophysics with the groundwater modeling or remote sensing. So that's the next phase, but we haven't got there yet.
Gotcha.
That's it.
Excellent. Thanks, Augie. Thibaut.
Yeah, no real big update on SimPEG, just writing and running new joint simulation for a paper again, but for the revision of the paper.
Cool.
Yes, that's about it.
Fair enough. John.
Yeah, well, I was sitting around a lot last week, but not too much on the development side, but I was playing around with 2.5D IP, and because we had this, this survey, I think it was in Manitoba, and there was an interesting contact where we kept getting negative chargeabilities through it on the one direction. And they were using LOC at the time, and it just wasn't handling it right. So then I went to SimPEG's 2.5D with just inverting for the voltages, and everything seems to be coming out pretty nice. So yeah, I kind of spent the week on that, just in my when I didn't have to do the running around, setting that up for everybody at the office. And yeah, they've been running 2.5D IP, no problem.
Yeah, so John, that's an interesting example because the typical data type for the IP is apparent chargeability. So that's where you have a problem, because if the polarity is different, and like from DC and IP, which would not happen that much, but there are probably some cases, like very few cases like that.
I've definitely seen it in terms of 3D effects as well.
Right. Absolutely.
In 3D surveys, especially.
Right. So yeah, in that case, actually just inverting for the voltage would be much better.
Yeah.
Other than using the apparent chargeability. So having both options is actually nice.
Yeah, that's why I went right to it, because they were complaining that they're having so much trouble. And I was like, oh, wait, Soggy and I were just talking about using voltages or chargeability, and threw it in there. And yeah, worked perfect. It worked well, I should say. And then I just been playing around with some machine learning again. I'm trying to move everything over to PyTorch there, and yeah, moderately successful so far, just in the last few days. But I guess that's not SimPEG related.
Still useful. Cool. Dom.
No new development on like the code part. I'm just doing more GUIs. I'm gonna give a demo next week, I think, on the 9th. Is it 9 next week or in 2 weeks? To do the Stitch 1D inversions. So yeah, and now I'm still involved with Diane on the carbon sequestration project.
Mm-hmm.
And then they wanted to invert so many things. So now I'm working on GUIs so that they can invert their mag and gravity themselves. So it would be like a single interface to be able to like basically grab data, downsample, and then just invert in one window, you know. So just to like streamline potential for inversions. Yeah.
What is that CO2 project? Like, do you have a specific field site that Diane involved?
Yeah, so it's the right now it's mostly focusing on the Surge 2 area, which is in the central BC.
Oh, I see.
And the idea is they basically want to find ultramafic bodies because that's the rocks that can capture the most CO2. And yeah, they're kind of like easy targets because they're susceptible and dense, so it's great problem for potential fields.
It's like a basalt. Yeah, I'm just kind of curious what that like.
Not basalt, but it would be sort of a serpentinized
Gabbro.
Dunite, yeah, gabbro or dunite, yeah.
Things with lots of olivine.
That's right. Devin got it.
And basically
10 points for Devin.
that can like because I think as far as I know, basalt, there's a geochemical interaction between CO2 and basalt that can sort of solidify CO2. Is that
yeah, but not basalt specifically. It needs to be olivine. The olivine needs to be like readily. I don't think it's olivine actually. It's brucite. Brucite is the mineral that they're targeting.
It's a pyroxene. We talked about this when we did TKC about the different kinds of pyroxene minerals and them having variable kind of like magnetic signature. So yeah. I think it was forsterite and brucite maybe.
Sounds about right, man. I didn't remember TKC this, but now that you're mentioning it, it makes total sense because as it gets oxidized, the magnetite disappears. And
yeah.
And then you can kind of gauge how much like sequestration power there is by like figuring out susceptibility.
And there's also it's like a magnesium and iron. So there's kind of some places in that mineral that can have magnesium and have iron. And if you have more of the iron in a certain oxidation state, you get a strong magnetic signature. And then if it's more magnesium, you don't.
You know your shit, man. That's good. I had Craig and Greg Dipple going at length on this stuff, and I still don't remember.
Oh yeah, that's a deep dive. But that's basically it. You can have some, some different replacements, different versions of the same mineral.
So that's the idea. I posted a link if you guys want to see what kind of the GUIs for the SimPEG EM1D is going to look like. I had to record it for training, and then you can download the notebooks and the data set if you guys want to spin it. And then yeah, that's it. So no new dev, but lots of SimPEG still.
Excellent. Is there any new news on the SEG workshop front?
No news, no. No, I think my feeling is that they're probably just waiting to see what's going to happen.
Yeah.
If the Olympics is not going to happen, I think SCG are thinking about it.
Yeah. Fair enough.
Everyone saw the announcement about the delay for the abstracts, correct?
Oh, I didn't see that.
It's April 15th now, right?
Yeah. I was surprised they didn't make that more like noticeable or out there, because there were some people that I had talked to that hadn't seen it either. So
Yeah, I would have thought Segment or something would have had that posted, but I didn't see it on there either.
Yeah, I didn't see anything coming on. Thanks for, well, not that, not gonna submit anything, but thanks for letting us know.
Devin, do you have any updates you'd like to share?
Not too many. I pushed my latest tutorials for the FEM and the TEM, and I think I took some of your comments into advisement and kind of updated those. And then I started to play around with an FEM inversion and kind of ran into some difficulties. I think right now we have most of the sensors are point receivers that measure total field. And that has its challenges with assigning uncertainties and inverting those data, because the real component is so much larger than the imaginary component.
In the frequency domain code, there are secondary field sensors.
There
is a B secondary. Yeah.
There is a B secondary, and I was trying to go with that. I've kind of run into some hiccups. So at least what I've got going so far is in the tutorials folder under temporary. So it's available to anyone to maybe see if I made an easy mistake. But I guess one thing I was noticing was, for lack of a better word, maybe that there was some inconsistency in the result if I use the EB formulation or the HJ formulation. So when I was trying to go and do some forward modeling, I kind of thought the natural thing to do would be, if I'm working with the resistivity model, I should be using the HJ formulation, and ideally I would want to be measuring magnetic fields. That felt like the more natural way to do it. And then if I was maybe measuring a B field, or I wanted to simulate the current density, I would work with a conductivity model and the EB formulation. Does that sound right with you? Do you guys agree with that?
It shouldn't actually make, I mean, a huge difference. Where you'll see differences is things are discretized differently. So if you're looking at, for example, in the EB formulation, if you were looking at the magnetic flux, if you're measuring B, if you've got a B sensor, it's going to be most accurate if you're closest to the faces.
Yeah.
Whereas with the HJ formulation, the B field will be most accurate when you're close to edges.
Yeah.
And so if you actually use the same mesh and measure in the same exact locations, there will be numerical interpolation differences between those two solutions.
Yeah.
Now, which source is discretized where also is slightly different, but there's no sort of, it doesn't strictly mean, if you're working with conductivity or resistivity, that you need to be using one or the other. Yeah, all the machinery is built in so that you can use either with each. The biggest difference is just where stuff is discretized, and that really matters on the SIL mesh. For the 3D case, it shouldn't be hugely significant. If you're using grounded sources, it'll be a bit different, because like where the current density is flowing is different. So like in the EB formulation, you have basically a wire that is defined on edges. So you have a very finite sort of footprint of your source. Whereas if you have, you're using the HJ formulation, you're actually defining current density going through faces. So it's basically, in a sense, a bigger footprint for your source. So those things are like slightly different.
Yeah, okay, because I noticed it was a little better using EB formulation with like an electric, or using a, I guess, a dipole source that was kind of defined as a representative electric current on edges. That made more sense.
Better.
Well, just based on the fact that I'm trying to model this on a very coarse mesh to make it very fast and just sort of qualitatively have it pass the eye test, it made sense that there was quite a large discrepancy.
Yeah, that's fair. Yeah. Yeah, if you're on a, I mean, if you're on a relatively fine mesh, the difference between the two shouldn't be significant. If you are like trying to cut corners, as makes sense for examples, you'll definitely see a difference between the two.
Okay, so yeah, I've just been playing around with that stuff, and I'm wrapping up a couple of very major GIF tools related things, and so I might put some energy towards the MT stuff.
Excellent.
So that's more or less where I'm at. I think we talked about all the GWB stuff. Everything works great. It's out, so that's kind of not under the SimPEG meeting. We talked about it yesterday, so that's more or less it for me.
Thanks, Dev. Doug.
Deb, just a couple of things. So when you talked about the MT, what were you thinking about? You said you were going to do some more on that.
I'm mostly just, I think, wanted to do a little bit of testing, understand it for myself, come up with a forward modeling tutorial. You know, it sounds like there's some interest that people have in actually using MT in the near future and using SimPEG to do it. And so, yeah, testing and seeing if we can find a way to have it be very usable for anyone else in the near future. We have a lot of stuff that we can test it against now. I mean, I've got field data sets for MT and for ZTEM, if that's put in there. And there's the stuff that we did for the manual, sort of our L block model. There's a lot of stuff we can really compare this against and validate it.
Okay, yeah, that's great. I think MT is surfacing actually from a lot of different perspectives. I was just talking to Dequan yesterday, and he's actually very interested in using MT, and they're trying to develop, you know, their own kind of MT codes. Well, actually, what they were trying to do was to use mod-EM and then modify that. But he's found that, you know, particularly frustrating. And so I was asking about whether he was planning to use SimPEG, and I guess he basically kind of, I don't want to say given up, but just got like discouraged a bit with using SimPEG. And I think if there was, you know, maybe a few tutorials and stuff like that to get them going again, it would really help. He's actually got a postdoc on things, and yeah, he was totally unaware about developments that we've done using local meshes and global meshes and the octree. So I feel that you know, here's a person who could potentially get quite involved with the development or the use of the MT code. And
Yeah.
so I think pushing forth on that would be really good. And Lindsay has put out a document. She'll probably talk about that in a bit. But I think focusing on that MT, which we've been talking about now for years and years, but you know, especially now with Joe here and, you know, spiffing up the codes and being able to serialize things and to look at, you know, combinations of different meshes for different frequencies, and just putting all the stuff that we kind of have in bits and pieces, but just putting that together. I think it's really the right time to do that. And so
yeah, and I think we'll need to, I think, develop and add a couple of utilities. One thing is that if you're working in areas that have significant topography, you have to go and shift the locations of all of your stuff so that it's defined on the surface of the discretized topography. Otherwise, you start getting electric field measurements in air cells, and that's going to cause some problems.
But we must have contended with that in the DC, would we not, Sagi?
There's
yeah.
Well, DC codes to do those.
Yeah, I don't think the utility's been written yet, but obviously we know how to do it. So that's something that that I was maybe going to do.
Okay.
But like these kinds of things. So start with all the tutorials we have, right? The forward modeling is, I would like to simulate some kind of geological scenario so that I can learn about it. And I'm going to come up with a survey, and then I'm going to have to create a mesh, and I might have topography, and just how would I go through all of those things. And as you go from what you're starting with to what you'd like to end up with, you find out that there is a certain set of consistent steps that you need to do to be successful. One of those is projecting onto the discretized topography, and then there's other things, mesh design, etc. So I guess I just start at the beginning and then see what I need for each step. But they're quite, I think that's pretty well established.
That's great. That's great. I'm really pleased you're focused on that.
Yeah, so I guess I was going to start with some basic topography, start with some basic idea of a survey that I'd like to do, and then when I hit a hiccup or I find that I don't have a utility that I need, then come up with a solution. We figure out a solution. Okay, move to the next thing. Hopefully things go smoothly. Oh, maybe we could think about this. That's sort of how I was planning on attacking that in like the immediate or moderate future.
Perfect.
Okay.
I would say when it comes to like, if you're looking for utilities and stuff, just ask first, and then we'll see if like, oh yeah, you can do it just like this really quick or something. You know what I mean? Instead of like, I don't want you to have to develop a bunch of time to like, oh, I need to come up with this all on my own. Like, oh, there might be something somewhere else. Like, I know Dom has kind of had that experience with me a couple of times. Like, oh, Joe, is there somewhere to like, yeah. So you get it. Yeah, I had a few other comments about MT stuff, and I figured Lindsay was going to talk about it later. So
okay.
Sounds good. Doug, did you have any other items?
No, I think that was about it. Most of the other stuff was GWB, and we kind of went through that yesterday.
Okay, excellent. Yeah, to give a couple updates, I've been working on getting an abstract together for SEG just based on the UXO machine learning work that I did for the UBC presentation. So I'll share that once it's in like a semi-complete form. Right now it's in very draft stage. So yeah, so I'm grateful that there's a bit of extra time on that. And then the other thing, as many people have alluded to, is the MT side of things. So I just dropped a link, and I think I shared this last time, but John, you weren't on the call last time. You were away in the field. And so, oh, sorry.
Oh, sorry. I think I saw it though. Yeah, you dropped the link there.
Yeah, I did drop the link. Excellent. So yeah, I mean, this specific document, and I think what we can do is maybe translate some of these things actually into a SimPEG discourse post, and that might be a good way to engage with DQuan. This specific document, what I'm going to do with this is be sending this to folks who are involved in the Jupiter Meets the Earth project. Just to give a sense of like where I'm planning on investing efforts and where we're planning on investing efforts in sort of pushing the MT case forward. But with that, then also identifying some specific tasks, both within SimPEG, but then potentially also within the Jupyter ecosystem. And so this, I think, is actually an exciting opportunity for us that, and granted, the things that you come up with for the Jupyter ecosystem don't have to be specific to MT. They could serve any sort of aspect of SimPEG work. So if there's something that's like, for example, you know, having a simple data viewer for different types of data, or that you could just like double click on from Jupyter Lab rather than having to, you know, launch a notebook, or things like what sorts of things would you actually like to sort of watch as an inversion runs. Joe Hammond has done some really cool work basically connecting Czar and Redis. So Redis is like a real-time data server. So actually, as an inversion is running, you can basically say, just like hang on to these live data for me, and that can be displayed. So things like looking at gradient steps, for example, or if there's any other intermediate information when an inversion is running, that would just be like helpful to actually have a look at. And potentially even make decisions down the line of like, oh, it looks like I set my, you know, my smoothness is not high enough. That step that it just took is crazy. Like, let's just kill it now and revisit. Yeah, so if there's anything like that that you kind of come up with or think about, feel free to add that to this document, and we can try and sort of prioritize what some of those things would be. The other thing I would really like to see is like the idea of sort of prototyping GUIs. So we've done some of that with the widgets work, but thinking about, you know, what else could we be doing to basically be prototyping or like building sort of research GUIs, but then also potentially prototyping some stuff that like Dom, you'd include maybe in Analyst or something like that. Yeah, so that's sort of like the Jupyter connection. But then also there is just the work of improving the code base. So I was kind of thinking, just based on this conversation today, that, you know, translating some of this into a discourse post might be a good first step. We can just kind of get like a lay of the land of what people's priorities are, and then, you know, figure out what's a way forward that we can sort of maybe carve up some of the work, because there's a lot of people who are invested in making this happen. So if we can, you know, slice it up into components that each of us can take, it'll get done a lot faster, which is exciting. Yeah, but I don't know if folks have questions or ideas or things you want to discuss on this. I know, Joe, you mentioned you've got some things in mind.
Oh, yeah, I just want to say I've been working on another project that was using the MT code a lot, and like Devin was talking about, like it was rough getting going with it because there's such a lack of the documentation on it. I feel like I got a good handle of it. I was kind of doing some local mesh interpolation and volume averaging interpolation to do some big 3D modeling on this fun. I was working on this project with BHP towards the end of the PhD. That was putting together they built this really nice like 3D model, and they're doing a bunch of tests and modeling with that and seeing if we can get more information out of it by using everything together. So I was doing MT modeling on that and kind of playing around with that. And as part of the inversion side of it, I did get some first pass scripts at building the sensitivity matrix already. It's kind of efficient way to do it. It was, without modifying the code too much, I think I got an efficient way to at least build the sensitivity matrix without doing too much repetitive work.
Nice.
Great. Wow.
So I can push that. I know John, you're kind of getting in with that on the Dask side of it, so you should be able to look at that and take something from it.
Oh, for sure. That'd be great. Yeah.
So what from your perspective, Joe, is sort of the major thing to be looked at from the code development part of a very flexible MT code?
I do think that, like as it's mentioned in the thing, that implementing boundary conditions, another approach besides the primary secondary formulation, would probably be a good way to go about that part. If we can get 2D implementations in there, I think that would be nice. If maybe we can look at switching the 1D implementation over to more of a semi-analytic approach, the same way that the 1D DC simulation is done right now. I think that'd be nice.
So you're talking about a 2D simulator for generating the fields for the boundaries, are you? Or are you talking about 2D inversions?
Just general 2D inversions like that. Like we can always, building these tools, we'll be able to use them to generate potential boundary conditions for higher order things as well, right? So I think that they're all kind of, it'd be nice to have them in there and things that we can add. But right now, like it's a primary secondary approach to it. So using it, switching it to like a better boundary condition type approach will allow us to use different types, like allow us to more easily use things like the octree mesh to speed that up as well.
Right.
Have you looked at how the UBC GIF codes accomplish this?
I have not seen any UBC GIF codes.
Okay, so I'm actually really quite happy with how the UBC GIF Fortran codes work, and I've documented the inner workings of how they do their modeling, how they implement the boundary conditions, and so maybe I'll send that to you. That's it's available freely for anyone. But there is a section that has all of that.
Would you mind actually dropping that into the?
Yeah.
I'd appreciate taking a look at that too.
No problem. But it works really well. And for the version 2 of the code, there is a way to implement boundary conditions from 3D. So I just have to find this.
Well, and one thing we could think about doing with the primary secondary is also, it would be nice, we should be able to actually have that as a source. So have the source keep track of if it's primary secondary versus not, and then go from there. Like that's what we do in the frequency domain code, which is kind of cool. So like, because it would be nice to hang on to that implementation just to have like, you know, things to check against basically. But yeah, maybe we can, if we can like stick that in the source, that would be nice.
Well, I think this is kind of how it works. Like it goes in it will solve a whole bunch of 1D problems with the model at the boundary, and then it will then use that and turn that into a source term, and then use that to go and compute the fields in the rest of the domain. I think that's the general idea.
Okay, if you have the documentation on that, that would be a helpful resource to kind of get our heads wrapped around that.
Yeah. I just I dropped the link in the meetings.
Oh, in the Slack, not in the.
Yeah. In
okay,
Slack.
that's fine. Yeah, we can also just get it archived in the doc. That's great.
Joe, in terms of the interpolation code, like, is that already implemented in SimPEG?
The volume averaging stuff?
Yeah, you mentioned interpolation that you worked on for like large octave mesh to a local mesh or something like that. Is that already implemented?
Not quite. It's another project I was working on. Like I have a good idea in my head of how to implement like octree to octree code or interpolation. It essentially goes through and searches for overlapping square or rectangular prisms and rectangles and 2D that should be able to generalize nicely to octree to tensor mesh. I think I had like a volume averaging branch going of discretized that has current implementations of tensor mesh to tensor mesh, which I kind of been building on that to use that as well. So then the only step, like I said, is just get octree to octree working generally. Dom has a small example of that with the with his tiled map. It's just that's a very specific one where every cell in a local mesh has to be in the global mesh. I'm trying to just make it a little bit more general.
Yeah, I had an implementation taking like the corner ends, right, the bottom and top corners, and then do like partial volumes, but it's just so slow. I mean, you need to vectorize everything, and
it's going to be really slow in Python to get around. So.
Oh yeah.
Yeah. Right.
Essentially, it'll kind of work the same way that the function that finds the containing cell of a point, you can recursively search inside the tree to get overlapping rectangles.
So, does anyone else have thoughts or things you'd like to bring up? We still have a few minutes.
Just one question there for Joe. When you were doing some of that MT stuff, what kind of frequency band were you using?
I think it was probably toward the higher range of frequencies. They were more concerned with characterizing near surface anomalies.
Okay.
I mean, they were only maybe looking, the model I think had a maximum depth of about 5 kilometers. So it wasn't that, I didn't have to go that deep or that such a long wavelengths.
Okay. Yeah, I talked to Devin about this here that last or 2 Fridays ago. Yeah, I'm trying to do like the high and the really low, and yeah, I just can't get the inversion to really do anything proper. But yeah, we kind of talked about that. It might be because of the meshes and how it's discretized. But
Yeah. Are you having any? So you're doing 3D modeling?
yeah, 3D modeling. Yeah.
I definitely found that like the first like it's really dependent on the initial model, right? Because if you get a horizontal initial model, the first step is not going to be able to fit any of the XX,
Oh, yeah.
YY, or anything else really, right? It's only going to be able to fit the YX and YY or YX XY components, right?
Yeah.
So it has like the first few steps are really tough if you start with flat.
Yeah. Interesting.
It worked better for me to kind of do like 1D inversions at each location and then use that to kind of create an initial model. And
that's a good idea. Yeah, I should try that as well. Yeah, my MT processors, I can't remember what code they use, but yeah, he was saying that, yeah, should be typical that you can just throw all the frequencies at it and go. And I'm just, I've been hearing otherwise. So yeah, Devin had a good spiel on that.
Yeah. I've seen some results of some codes where they say, oh yeah, we hucked everything in, and I don't know what's happening under the hood. Maybe they've got something really, really fancy and spiffy. But if you're just going to invert everything on a single mesh, I always thought 2 to 3 orders of magnitude of frequencies and subsample it. Pick some good ones, assign proper uncertainties to them. Yeah.
I agree now, totally.
I've actually just posted I'm building the GIF Tools cookbook website right now, but I've actually just posted a full comprehensive tutorial for how to start with standard MT data and how to go from having that to getting your final inversion result, and all of the things you would do to understand the anomalies and interpret the data and what decisions you should make. So it's gonna take maybe like 20 or something minutes to build, but I'll drop that link as well because it's kind of a standard practice for how you would invert MT data.
Right on, I'll be reading that.
Perfect. Yeah, anything else from anyone?
Dev, remember we talked about like the latest UBC code handling the topography. There was an option, right? Like I think it was either a 1D option or a 3D option. Was it captured in that document?
Well, of course it was, Sagi. I'm thorough.
Great.
I think that, yeah, the 1D one makes a lot of sense. The 3D one, it's really hard to get an intuition. And I think Eldad came up with it and then got Roman to go and use it. And then we documented it as best as possible. But I would be lying if I said I really, truly understood exactly how it was working.
Yeah, so that's one thing that probably need to explore a little bit more. And then think about, I'm not even sure how to test it. Once you got topography, you don't really know what's actually exactly going. So yeah, it'll be worthwhile to revisit and think about how are we going to test that. And then if we figure out, do the test and make sure things are properly working.
Yeah. Well,
that's one sort of like a Pandora box we haven't really opened up.
Well, I think when I don't know if there I don't have a paper for where it would have come from.
The latest, okay.
I had field data that I inverted to show Rio Tinto how to use our codes, and it had very extreme topography, and we got quite good inversion results with the code, and I used the 3D boundary conditions. And we know we have good results because it was able to actually kind of match or better inversion results that somebody else had done before and drilling results. So when they saw my my answer, they said, yeah, that's what's there. So
I'm just throwing things up at that. Like another thing is like what's people seems like using in practice rather than just inverting for the impedance. I think they put some sort of coupling, like a coupling tensor or something like that to handle the static shift. So like the current, our current approach is like basically use the 3D code and then let the near surface like really have like very complicated structures to fit that static shift. But there's another approach what people are using, so you're simultaneous inverting for those like some sort of coefficient, and yeah, I don't know, but like I'm not sure like that one is really working, but that's another avenue.
yeah, we didn't.
I feel like I remember seeing that written up somewhere. Do you know?
You mean the paper?
Yeah, is there a paper for that or an abstract? I feel like I remember reading about that.
Well, I'm pretty sure there are like lots of people worked on that. Like I think I'm not sure is like some sort of coupling coefficient. That's how they are calling it. But basically, you're inverting for those static shift. So you make an assumption what that effect is, then they are basically inverting for it.
Okay.
Like an
I
average.
think maybe one of the earlier papers on that may have been by Catherine de Groot Hedlund many years ago at Scripps, where she was inverting for static shift parameters as well as the conductivity.
Okay.
I guess I always thought that the static shift, there was like a processing that could be done to limit it before you got into inverting it, that you wouldn't do it simultaneously.
That was sort of the modus operandi for many years when they couldn't really have reasonably fine meshes and model things out with 3D. But I think more and more people are just turning to modeling it out with 3D. If you can have cells that are fine enough, you can put in little bits of conductors here and there in the near surface, and that's going to sort of absorb the static shift effects. So I'm not sure where people stand, but my understanding more and more is that's what people are doing, and they're not actually trying to compute what the static shift parameters are. Alan Jones might have a different view on that, but that's kind of where...
we could basically have a little bit more fine discretization, I think.
Yeah.
Like around receivers, and that should be...
Well, with the octree code,
yes, that should be fine.
It gives you that flexibility to do that.
But then you also, one of the other things we think about is how sensitive the cells next to the receivers are, that sensitivity. And so we usually do this interface weighting on the near surface cells to kind of, I don't know, reduce the freedom of the near surface to be able to be somewhat pixelated. So you're kind of, those two things are fighting. So you want those near surface cells to be able to get these small scale variations in electrical conductivity to explain the static shift or sort of to account for that. But then you also don't want to shove everything right next to your receiver, and you want to put structures at depth.
Yep, that's a good point. Completely valid.
Yeah, we're reducing it, right? So we're reducing that impact as we go. So hopefully inversion will figure it out.
Well, we just need somebody to write a good workflow and design parameters. No problem, Dev.
Yeah, exactly. All right, excellent. Well, we're coming up on the hour, so we can wrap up here. Any last minute questions, thoughts?
I know I brought it up last week, but would anyone like to schedule a happy hour, virtual happy hour at some point later this week together?
Oh,
yeah, let's do it.
Could be good.
I don't know what people's plans are, but I mean,
are we creating a team?
Yeah. And also, Joe, are you supplying the
virtual liquor?
YOB.
virtual liquor actually works.
I've got an abundance. I could try and get it there and rush delivered.
Well, John, I mean, this is actually quite fine because I don't actually have to touch you. You just drive up to my home, leave all of the booze on my doorstep, and we're good to go.
Get on my bike and I'll self-deliver.
All right, guys. I need to head out, but let me know if you're doing virtual happy hour.
We'll get a time set up at some point over Slack or something. But
Let's do Friday, yeah.
yeah, Friday.
Yeah, Friday.
Friday would be great.
Friday works.
All right. I will see you all on
All right.
Friday.
Bye-bye.